Now, people also say, "What's the encapsulate?" Go ahead and mark to 11A.
We just missed the first speaker, Lina and Albert.
The first what?
Speaker, Lina is not there yet.
Yeah, that's
Albert is not. Albert is arriving. That's good. Just wait a couple of minutes for Lina, otherwise we will move and switch the presentation.
Wasim, you want to pick up the blue sheets?
I couldn't use it last time because there was a bug in the version.
Good, you?
And then running it was
Did it work?
Yeah, there's one problem with this. I wish I had one more people to figure it out.
You should write, our names are on the top of them. So
Yeah.
remember, literally all they do is scan the sheets. So.
Yeah, now I'm drawing. This is not It means you didn't have to travel far this time.
Yeah.
For a change.
For once.
Do you feel jet lag? Do you feel jet lag?
A little bit. It's 1 hour and a half flight, man. It's longer distance.
That's just enough time to not get started on any work.
Here we go.
There we go. Okay, let's get this shown.
So hello everybody, welcome to the Lisp working group. Okay, we have a 2-hour session today. On the screen, as usual, not well. Everything going on in this room in the next 2 hours is an IETF contribution. You read already the not well during your registration process. Blue sheets are in principle already going around. Okay, few pointers about charter, etc., etc. I always forgot to put the meeting pointer. Quick status. We are running under a new charter, which has been approved slightly after the last meeting we had. And we did good progress on the documents. So we have a couple of documents that are already in a RFC queue, and 3 for which we closed the last call and the write-up has been submitted. The last one was this morning for the LCAF document. So everything is now in the hands of our ID, Deborah, sitting on the back over there, and the ISG that has to do with work reviewing. Okay, next step will be the security document, which ASAP will be reviewed, and then we'll see to push it as well for publication. We have an open call for adoption on the mailing list running for 3 weeks now. Okay, it's the document draft Bugader Lisp type IANA. So basically, he's asking to set up an IANA registry for the console plain message type, okay, which are currently defined in 6830, okay, and in a couple of other RFCs. And yeah, that's the basic content of this document. Now, on the mailing list, there was not that much going on. I mean, since there is anyway the call for adoption, everybody should shout and say, I agree, I disagree. If you disagree, you don't think it's a good document, explain why, obviously, in order to improve. Okay, but otherwise, if we don't have feedback, we don't make progress. Okay, so please comment on the mailing list. Last update, Damian was, I forgot to mention Damian Wasim are our secretaries today. They will take note as usual, but Damian is asking to step down at the end of the year. So we have a new position available. Any volunteer can contact us, Luigi, Joel, the chairs, and yeah, would be good if somebody can help Wasim that hopefully will not step down as well and by the end of the year, right? You are not allowed to. Okay. So the agenda, we will start with a quick update on the Young model, which is a working group item. And then we will have a long session on not yet working group items, starting with Albert presenting a proposal for rewriting 6830 as 6833 bis. So basically, it's the data plane and control plane of Lisp. Since we're under the new charter, we will reissue the documents as proposed standard. It's also the occasion to review the protocol itself in a little bit. We will start a discussion today, and then we will go on with a few other things, concluding with a long session of Dino talking. Yeah, you are not allowed to go over time. Yeah, on a few new work items that potential. Yeah. But just to, I put every document he will cover as a separate item in the agenda, just for the sake of clarity. But actually, the last 3 items here is just one presentation of 10 minutes. 10 Dino minutes. Could be slightly longer. Okay, yeah. If you don't have any comment on the agenda, we can move forward, and Dina can come. You stay in the green,
As long as you're in the pink square, and just take the mic out of the stand. It's easier.
Okay, so hi everyone. This is a very quick update on the Yang model draft. Since the last presentation, the draft was adopted as a working group item and is now in the -03. So the main model is the list. The core of the model is captured in the IETF Lisp, which basically includes both config, operational, and the common groupings like the mappings and locators and so on. Then it essentially allows for configuring a list of Lisp roles, and then this list, or the different types of roles, basically can be augmented or are augmented in different models per each role. So then we have augmentations for ITR, ETR, map server, resolver, and so on, which each module within augmentation captures Lisp that specific configuration for that role. Then aside from these, there's the Lisp address types, which covers all the basic and LCAF address type in a single main grouping. And I'll do a very quick overview of those. So this is kind of meant to capture the high-level view of how the Lisp address types are organized. So basically, we have a main grouping, which is a Lisp address, which covers IPv4, v6, prefixes, and also all the LCAFs in a single choice of addresses. Yang doesn't have a good support for recursion, and the LCAF models are recursive. So what we've done is put up to 2 levels of kind of recursions, modeling that. So there's a list of simple, there's a type defined as a simple address, which covers the well-known AFIs, IANA registered AFIs, not the Lisp LCAF AFI. So IP, MAC, AS number, and so on. And within the first level of recursion, so basically inside the LCAF types, if there are Lisp addresses, they're defined as those simple address space. Then this is kind of covering how the augmentation for each role is done. So, for instance, the Lisp map resolver module is augmenting the list of roles, and when the role type is a map resolver, then additional configuration is put here or modeled here for map resolver. So in this case, we have a very simple, just setting up the type of the mapping system that this resolver is participating in, and then if the type is a simple single map resolver, then the MR will need a pointer to a map server. Then as an example, if basically more complex mapping system types are needed, for instance, for DDT, we have a DDT augmentation or a DDT module that covers all the DDT specific configurations that are needed for both map server and map resolver. So for instance, in this case, the map resolver module is augmented to include a DDT route or a list of DDT routes for the map resolver. Then the module includes also similar augmentations for the map server configurations that DDT would need. So I think that's it. Just covering the overview of how the models are organized as of now, and asking for some feedback and input. The only thing that is kind of a question to the working group specifically is that the title of the model, not the name of the draft, but the title of the draft is actually Lisp configuration Yang model, and since it should cover both configuration and operational in one, then I think it should be changed to Yang models for Lisp, which is similar to how other protocols are titling the Yang model. So that would be just a title change request. And with that, that's it. Open to questions.
Questions? Yeah.
Can you please send the suggestion of retitling it to the list so that we can then judge the response? Sounds like a good idea to me, but let's get it to the list.
Sure, I'll send an email today.
I have just one question. There was on the mailing list in the previous version of the document, I think Benoit Claes sent an email stating something was
correct.
Correct. Did you fix in this
Yes.
iteration already?
Yes.
It's done. Okay.
Yeah. So there's a Yang parser validator now, and actually that has been added to the submission side now. So you can when we're submitting now, we can just validate.
Okay.
Before it was separate, so it was a bit. But the -3, which I uploaded a couple of weeks ago, fixes all of that.
Excellent. Yeah. Thanks now, Albert.
Okay, great. Okay, so first of all, I would like to explain a little bit the context of this presentation. So this is text from the charter, and we are chartered to, actually the first and high priority work item is to develop a standard track solution based on the main Lisp spec. And we are entitled to do so in 1 year from now. And we are chartered to do 2 documents. The first one is unicast data plane specification, which is 6830 bis. And the other one is control plane specification, which is 6833 bis. So in this presentation, what I will make is a review on the current spec, on how we can split this spec, which at the end is the goal. This has been done along with Dino and Damien. I am not entirely sure if this presentation also has your full opinion, so feel free to go to the mic and say something if you don't really agree with what I'm going to say. And so my goal is to trigger discussion on those 2 items with at least a proposal. And to me, the rationale is to try to do mostly an editorial work, to try to split the document in 2, so pretty much the text, rewriting what's necessary, but do not include any new features, and so on. This does not mean that we should not also include fixes that we are aware of and some lessons that we have learned out of the long experimentation. So if you take a look to the contents of the main Lisp spec, we have all these, let's say, sections and features, right? We have the Lisp encapsulation, MTU handling, instance ID, then all Lisp control plane message, routing locator selection, then how to understand if a locator is reachable, then some comments on EID reachability, how to hash them, how to update mappings, and then several deployment considerations for mobility, for multicast, and for network management. And what we are proposing, is to split it this way according to this color code. So the blue means 6830 bis, which is the data plane. The red means 6833 bis, which is the control plane. Then green means other, right? That we should put that text into another document. Then orange, which is between blue, right? And I'm not very good at colors, but I guess that orange is between blue and red, means that actually this section should be split between the 2. And black means that I think that we require further discussion. So as for the data plane, clearly the Lisp encapsulation should be on the data plane plus MTU handling plus information about instance ID. Then, as for the reachability of locators, we have pretty much 2 mechanisms, which is econons and airlock proving. And to me, econons should be on the data plane because it's data plane. It's piggyback on the data plane. Then text regarding EID reachability, routing locator hashing is also data plane. And then on how to update mapping, so if we have a mapping and it's outdated, how do you update it? There are pretty much 3 mechanisms, which is clock sweep, SMR, and map versioning. Since map versioning depends precisely on the data plane, I think that this should be also on the data plane. Then there is a bunch of text, which is not specifically specifying anything, but it's more informational, like deployment considerations, multicast, mobility, and so on. I think that clearly the trace route consideration should be on the data plane, and then the other sections, which are in green, should be in the corresponding graph. For instance, multicast considerations should be on the multicast graphs, and so on. Then, with respect to the control plane, we should have all the 4 message for a main Lisp control plane message. Then we should have also SMR as a way to update mappings. And then, honestly, I can't remember why we discussed putting routing locator in the control plane. Yeah, me too, actually. I was saying to me, this should be also in data plane. So this is wrong, this should be blue. And then there are certain sections like airlock proving, clock sweep, and mobility considerations for which the authors, we didn't reach consensus. My opinion is that airlock proving should be also on the data plane, clock sweep should be on the data plane, and mobility consideration should be on the mobility document for which we are chartered to do so. So I don't know if someone wants to voice their opinion with respect to this.
This is Dean. I just have one quick comment. If we put the mobility considerations in the mobility document, it's still an individual submission. So would we put a reference from the BIS to individual? That might be problematic, but I don't know what to do about that.
Luigi, I have the opposite opinion. And my opinion should go out from the data plane and the control plane and put it in whatever mobility document the working group will adopt, because we have it in the charter. So at some point we will have something. So of course we have to keep this text around, but move it to whatever other document. So I would like to give my personal opinion on a few things. So the green stuff, a lot could be just dropped, in my opinion. For example, deployment consideration, we have a whole RFC already talking about this. Yes, we can still go over this text and really evaluate it carefully if there is any information that is missing from other documents, but otherwise, I think these are covered by other documents. So we can just drop it. Yeah, maybe routing locator selection, data plane did a mistake.
Yeah, that's a mistake.
On the black boxes, clock sweep and RLOC probing. I mean, RLOC probing, if you look at the text that we have today in 6830, states is a control plane mechanism. So my opinion is this should go in the control plane. My opinion. Clock sweep is more a management thing, how you manage the mappings, how you use the control plane in order to control the distribution of the mappings. I would say as well control plane, but again, it's just my opinion.
About our log probing, Luigi and I have been going back and forth on this. It turns out we're doing this document separation because we want to have a data plane only document and a control plane document where other data planes and other working groups want to use it. So if VXLAN or the NVO3 working group wants to use the Lisp control plane and they see RLOC probing in there, they're going to wonder if that's part of the control plane. RLOC probing is an OAM machinery, and they may not use, they have their own OAM, so they may not want, they will need to be informed that they don't have to use it because they could use their own. So, I mean, RLOC probing is there for the Lisp data plane to do Lisp crypto, to get to not do mapping entries, to find reachability. It's control plane, it's not in band. They're making all those decisions now in NVO3 on how many different ways they want to do OAM, right? And they already have 4 internet drafts on how to do it. So this could complicate that matter or other matters.
Yeah, go ahead.
You have a point there. I agree.
Literally from Huawei, so I see like 4 parts in this picture here: data plan, control plan, and some like applicability or use cases. But another important part is the mapping server. So I see that mapping server is not unique to Lisp here. Actually, if you see in other working groups, we have heap and also have the older ILNP. Recently, I'm also seeing like IAOA there. So maybe mapping server can be abstracted into something. So that would be globally like shared by all these kind of ID related protocols, so that on the Lisp part, we can focus on the data plan and also the use cases, for example, like mobility, so that the people can focus that. Because if you look at Lisp like drafts or IFCs, I see a lot, right, from the older ways, right? Max right now is a DDT, that's probably the latest one, right? So I do see that so that's if we just focus that on the Lisp group, so you know why should not like open it, let more like contributors from other working groups and look at it, because the problems is not unique to Lisp here, like how to scale it and all of that kind of thing. So that's just my personal opinion.
This is Dino. I just want a clarification. Are you saying that the mapping transport system that connects map resolvers and map servers together should be open, which I think it is, and modular? Or do you think that the way you communicate with a map server should have different types of methods?
Right, okay. Just for speaking about mapping server itself, right? I already see enough problems here, right? So how make your mapping server like, let's say, secure and robust, and also on time, and also Lisp, there are lots of cache here. So certainly it's good if we have a unique and a global one that can be shared by all the ID related protocols, that would be good. But if not, and at least like Lisp group can send some requirements, let's say as an input to the upcoming mapping server work. So in that case, and we just focus Lisp itself and then push like a mapping server related work to somewhere else so that more people will work on it.
No, I think that this is a good idea. So as we are or the way I understand the control plane in this presentation is the front end of this mapping system that you are referring to, because later you will see that in the map server we only explain how to process this message. So I think that should be on a separate document, not to mix with the signaling precisely. But I agree that this should be a nice work. Yeah.
I just want to, this is Padma Playas now, why? I just want to add a comment to what Richard said, is that I think that services like mapping server is universal in anything that's trying to do a mapping on IP. Mm-hmm. And not only that, but I think to every one of those different applications, and it can be mobility, it can just be anything else, is beyond what we are looking in one working group. Mm-hmm. And this is something that I think really we would like to have, is actually a broader set of requirements. And that means more than just the front end, but also you can imagine in the future, maybe you have things like past computation elements who in the back end inject things in your mapping server that makes it an intelligent mapping server, which is way beyond just this working group.
And you are suggesting to have this in the Lisp control plane document?
No, right now I am proposing to have the mapping server as an independent work that benefits the whole of the routing.
So quick comment. I think that the Lisp control plane is providing or defining, specifying the API to look up and resolve things from the mapping service. And the architecture of the mapping service itself, the deployment and how it's done, the algorithms that are built on top of it or inside it, are not part of the things that are standardized or defined in the drafts. And they should not be. So that should be up to the implementer to decide what smart algorithms to put on top or additional things to do. The protocol for lookup and resolution, however, is part of the working group, which are the specifically those items that are in red, Albert mentioned. So the map request, map reply, notify, and so on. So those, the protocol is specified, the architecture, implementation of the map server, whether it's DHT or DDT or other things, we can propose things, but it should not be standardized.
Well, Vina, I want to emphasize the first part of what you said. The architecture we've been working with has very strongly had that segregation. And the Lisp documents, these Lisp protocol-based data plane and control plane documents need to preserve that. That doesn't mean we can't. We do document and we can standardize mapping server systems. The Lisp DDT, I sure hope we're going to publish that. People need it. But that's separate from the specs that Alberto and company are leading us to produce. So I think it's very important we keep the clean interface, which we have defined. And yes, we can add new messages to it if people conclude we need them. There's been some discussion of that. But that's separate from whatever mechanism you use to implement it, whether it's an oracle that just magically knows it, it's DDT, or we did the BGP one. Wasn't a great choice, but we did it and it worked.
Completely agree. So we have DDT now, and we can propose new ones. But that was exactly my point. So the API has to be separate, standardized, and it can be extended as the working group is rechartered to cover new requirements from new data plane protocols. Absolutely. But we have to keep that separate from the architecture of the map.
May I add a comment? In this case, for the working group, think about if we need a registry for the console plane message type. We will have an open call, so think about it.
We do have an open call for comment on that.
This is Dino. So Vina brings up interesting points. I have some data points which might be interesting. You know, I talked to hundreds of people about Lisp and stuff, and they seem to understand the API to the mapping system because it's like any other database mapping system. What they seem not to know about is how does it scale? And then when you just reply with a single sentence saying it's kind of like DNS, they go, oh, that's okay. But I think we need some more education on how DDT works. And I think that might be presentations, or maybe it's what you said, Joel, is actually getting DDT progress a little bit better.
I think that getting the DDT doc out will help that.
And I think we need to do more trials on DDT. We had that when the document began, and we need more experience with it, because that is where the hard problem is, right? Everybody says all these working groups in the IETF just say we can use some control plane, and they don't realize the scale that they want to use it. They want to use it for cellular, they want to use it for IoT, and everybody says, oh, I'll just use somebody else's control plane, and then magic goes here, and nobody's really doing the hard work. You know, we have a lot of experience. You know, we've done 6 mapping database systems over 10 years. I had to count them up because I'm doing a history presentation, right? And so we put a lot of work into this, but nobody seems to know about it. So I just think we have like a marketing problem or something.
Okay, Jeff, go ahead, and then I would like to make sure Alberto continues, because we need to get through this.
Facebook folks during the presentation mentioned today 50 million objects going towards 2 trillion. So something to learn from. And it's working today. They're deploying.
Okay, so may I comment on all the questions? So I believe that the red parts, removing routing locator selection, produces a very, very compact control plane, which is, of course, very flexible, which has plenty of use cases, which should be on a separate document to me. And I agree that it could be relevant to explain those use cases and the requirements. But to me, the control plane should be only the interface, and that can be used across many other use cases. Then I understand that more or less we have an agreement that, so this is wrong, routing locator selection should be blue, airlock plugging should be blue, clock sweep, okay, and mobility consideration should be on the Lisp mobile node document, okay? Okay. So then this is the table of contents more or less of the Lisp data plane 6830 Bs. So at the introduction, we should remove the description of that Lisp can be used to scale the BGP default free zone, and indicate that it's an overlay protocol, that it's a data plane that supports many different control planes. Add a reference to the deployment consideration. A few more notes that you have, or you can watch you can see the slides. Then we also propose to add the RTRs as a new term in Lisp. And in the basic overviews, mention also the RTRs. Then, as the packet flow sequence, which is like the life of a packet example, I think that what we should do is to explain that the ETR at the end, what it does, it checks the map cache to obtain the airlock. And where does the information come from the map cache? It's on another document, or you can use different mechanisms. So the map cache is the glue between the data plane and the control plane, in the case of Lisp. Then you have all the Lisp encapsulation details with a few notes on NAT traversal that you can see on the slides. Then here we propose to remove section 6, which was map register, map requires, map reply, and so on, to a section that specifies how this map catch works and that describes how both documents interact. Not specifies, but explains how both documents can interact. Then we have the MTU section, which is section 7, section 8, which is instance ID, 9, routing locator selection, then the reachability with both actually econons algorithm and merge log probing, as we agreed, then locator hashing, then how to update the contents of an EID to RLog mapping, which I understand that now is map versioning plus clock sweep, trace route consideration, community consideration that goes out, and that's pretty much it. And security consideration, sorry, where we can add now a reference to Lisp threads, to Lisp crypto, and to Lisp sec, right? So at the end, this is the blue codes, but with text, and that's the Lisp control plane. What we should change the name of the document from Lisp map server interface to Lisp control plane, and show that in the abstract, explaining the introduction very early in the document that this is a control plane that supports many data planes. Then in the basic overviews, explain that the mapping system can be composed for many nodes, that this is on other documents, and that there may be nodes that are not neither map resolvers or map servers. Then describe all the Lisp control plane message, map request, map reply, map register, map notify. Also include here map referral with a pointer to DDT, which is again a message in the control plane. Explain, specify how you can encapsulate a control message packet. And then the sections this is the complementary document, right? So the sections that we remove from the other side are here. So how to update the contents of an EID to RLog mapping, which at the end will be only SMR. Map server processing, map resolver processing, security considerations, and that's pretty much it. Okay, so more comments or questions? Great.
I have a comment or other question. What if we really want to show in this document that is a generic console plane? What about putting a couple of examples? One is Lisp, another example is not Lisp, and how to use this console plane. What do you think?
But are you thinking about a specific one?
No?
A specific encapsulation or?
Something. I don't know.
To me,
think about, I don't know.
To me, so at the end, to me, the life of a packet that we can put at the beginning and the introduction, it has a lot of value because it has people to understand very quickly how things work, right? At the end, then the specificity of the map requests, you can just read them and that's it. This is how it works. So to me, this makes sense. Yeah.
Yeah, it's literally, maybe I have missed. Should we have something like talking about the Lisp side and non-Lisp side? How can we make them together, right? Consider that like Lisp already almost 10 years, right? So if we like deploy it, so I can imagine that, so network, like not everywhere is Lisp operated. So could we have something?
So you mean interoperability between Lisp sites and non-Lisp sites?
It's not just interoperability. Here there are a few different things, like two Lisp sides goes on non-Lisp side talk to the Lisp side, and also for the mobility that thing there, you have like 4G, 5G core there, so you are using Lisp technology there. So it's not simply just like an interconnection or translation there. So probably there are something there, but it's just come to my mind.
So let's be a little careful because the existing document already deals with interoperability between Lisp nodes which are using Lisp. I don't want to say Lisp sites because it's not about sites. It's a node that is going through a Lisp ITR, and nodes which are not using Lisp, and that's dealt with and will be dealt with in this revision. The question of, well, the middle doesn't use Lisp, that's a non-issue. Lisp doesn't care if the middle uses Lisp. Yeah. The question of mobility is going to be dealt with in the mobility documents. I don't want to shove all the interesting potential future cases into this document. But the base mechanisms are there, which are the mechanisms we use then, like the proxy ITR and proxy ETR, are the mechanisms we use then in the other cases. But I don't want to try to get too much in these cases. Dino wanted to add something, and then
So just so to complement what Joel said, there are documents specifying this. There is one document which is called Lisp Intro, which gives you the big picture.
It's actually, it's just more than that, right? If you look at Lisp like data plan, so IT actually essentially IP addresses, right? So you have two IP addresses inside, syntactically a list, right? So somehow your like ID in your Lisp side makes sense, that's ID. But somehow maybe a misconfigure, maybe something, it goes to a non-Lisp side there. So legitimately they will take the IP addresses, so they don't take the SID there. So somehow, somewhere, so probably we make clear. So maybe I'm wrong, maybe I'm wrong. Yeah.
Renwei, there's an RFC for Lisp interworking that defines how non-Lisp and Lisp sites talk to each other. And that was the reference Joel made to PXTRs. There's also a deployment RFC as well. And then, of course, EID mobility is done in an internet draft that will become a working group. So we have all these, and they're trying to have clean interfaces and be modular in a document sort of way. Right.
You assume that your network is correctly configured. Suppose, as I said earlier, somehow like you have a decap take the outside like tunnel out, because it's a really ID encapsulated packet. So the IP addresses should not be taken as IP addresses, but somehow it goes into a non-Lisp side. So in that case, they will use ID do the routing. So in that case, what will happen? So because in all the Lisp drafts, I haven't seen anyway. Maybe that has been discussed.
All that has been covered in the interworking RFC. Yep. I'll send you a pointer.
I think that you're right that we have too many documents. And so just to finish, so to me, and I hope that the chairs agree with that, this should be an editorial work, meaning that we should pick the text that we have, that we know it works, and we should split it. Of course, we will need to rewrite something just to make the story work. But we should not add new features or anything, otherwise this will be endless.
If somebody discovers there's a bug, we'll fix it. But the expectation as part of the rechartering was, we have the right technical material, we need to make this suitable for PS.
Yeah, and I'd like to make a call for all implementers to look at the document carefully, because if there's something that's in implementation that the working group kind of pseudo agreed on or needs to be fixed, this is the time to do it, right? Fix bugs, right?
Yep.
Okay, thank you. Next one.
Okay. The presentation is about this document, Lisp multiplexing and header compression, which proposes two different things and two combined things. Multiplexing on the one hand, which means to send together a number of small Lisp packets into a single one, and it will share a single Lisp header, and this results in bandwidth savings by overhead reduction, and also a packet per second reduction. We are using this draft, Simple MOOCs, which has been submitted to the Transport Area Working Group. Basically, it adds source separators between the packets, including the protocol field and the length field. And well, here we have put a link to a research paper about it. And also header compression to the inner headers using ROC. Why multiplexing? Well, this is the histogram of public internet traffic trace, where you can see that 1/3 of the packets are very, very small, 60 bytes or less. These are the almost MTU packets or MTU packets. This is the average. But the fact is that there are lots of packets here. So, well, this would be a scheme of the idea. You have 4 packets here to be sent to this other network through the unlock address space. So you can do this, adding to each one a Lisp header, This is the Lisp tunnel overhead, or you can instead do this, which is just adding one and sending all the packets into a single one. In the draft, we have proposed three methods. The first one perhaps is not very elegant, so you may find it not very good. It's just putting a number of packets after the Lisp header and using the length field of the IP header, you can guess if there are more bytes or not. In fact, we implemented at the beginning, the first time we implemented it, it worked directly with the Lisp mob implementation because there were some bytes under the ITR was able to extract them. And there is also this number two, multiplexing method based on simple moocs. You use simple moocs separators to indicate the length of each packet inside the single header. And this allows you to use this third one, the header compression combined with multiplexing. It's like two, but you can flag the length of the packet, so you can use header compression to the inner headers, IP, UDP, or even RTP. Let's see some.
May I ask a question? For your basic approach, did you think about using the source part of the UDP packet, some encoding over there, instead of just putting a number in the middle of nowhere? Maybe something to think about.
Yeah, yes. Yes, you can perhaps put a different port number to flag that there are different. Yes, in fact, that's saved in the document. The question there, well, is that if you use rock, you may also try to compress things. Well, it's more elegant with simple moocs, but I don't know. Perhaps it also makes sense. We can try and do it. So this is a real example with 2 packets of 100 bytes of payload. This is the IP, the UDP header, and this is the payload. These are 2 packets. This is the normal Lisp behavior. If you use a single header, it's clear, you save this. If you use this small simple mooc separator, which are 2 or 3 bytes, they can even be 1 byte in some small packets, you can save a bit less. But if you compress these headers like this, you can increase the savings. These are some results. We have modified the Lisp mob implementation, thanks to Albert, who helped us with that. And it's also available here, our modification. We sent, we had 1 megabit per second link, and we were sending more than, well, 1.5 megabits per second of UDP packets with 100 bytes payload. So the link is clearly saturated. So this is the size of a packet with one simple moocs header. So we are here. If you do nothing, you have 50. This is at application level, 552 kilobits per second of the application throughput. If you don't compress headers but only multiplex packets, you can achieve, if you put 10 packets inside, 742 kilobits per second. And if you also compress headers, you can achieve 900 kilobits per second. But you are building bigger packets. Obviously, you have packets of 1,000 bytes or even bigger. So you get a throughput increase of 34% or 64%. In the list, we also discussed some use cases. These are some of them. I have a number of packets in the buffer. For example, voice over IP, games, machine-to-machine, IoT traffic of samples generated by a sensor. So I can, for example, do another queue of small packets and then put them together and send them. This would also be combined, I don't know, with some additional delay. For example, in machine-to-machine or in IoT traffic, some small delay may not be critical. For flexibility, I can have this in a middle box and only activate it when needed. So I don't need to dimension the network for the worst case. I activate it at congestion times, and instead of having a recurring bandwidth cost, I add one time this new capability, and it's only a one-time investment. Energy savings with PPS reduction. Well, we are saying this. We have some papers that say this, but we have never, in fact, yet measured the energy savings. And also from the list, Dino suggested this idea. The fact that queuing is happening while waiting for a handoff can be a good opportunity to pack IP packets into bigger frames and to send them. And this also may be useful in mobility tunnels. Well, this is an example of PMIP version 6, where there are some tunnels used for mobiles, so you have a lot of packets to send in the same tunnel. And we have also added this. How could we integrate this in the current Lisp environment? How can an ITR decide which encapsulation to use and which flows to multiplex when sending the traffic to a particular remote endpoint identifier? It's not yet in the draft. It's not implemented. We are waiting for your feedback to know if this is interesting, so we could implement it and test it. We could use the Lisp canonical address format for this. We can enrich this signaling to carry this meta information concerning whether or not to multiplex packets to a block of ADs, and whether or not and how to compress their headers. We could use this Lisp canonical address format based on several parameters: the source, the destination addresses, the type of service application, etc. And we could also extend this encapsulation format type to tell on a lookup to the ITR what the ETR is willing to accept, if it implements or not multiplexing or whatever, or different, for example, delay requirements or these different things. So, okay, this is it. We are now in this stage. It works, but now it only works without signaling. We just put in one end, we put it in the other end, but they don't talk about there is not a negotiation of or a questioning about are you multiplexing or not. Okay, that's it.
Any question?
Just a couple of quick comments. One is to look at VXLAN GPE to see for the encapsulation part, maybe you may have there flexibility to allow you for the multiplexing. And the other one, when you say signaling, do you mean signaling between the XDRs, or do you mean via the control plane? Because I think it would be useful to involve the control plane here, right? Because you know the capability of the destination, and then you can map to the appropriate attribute.
Okay, thank you.
So Albert from UPC. So when you mean negotiating, so this could be a new encapsulation, as you said, and you need to negotiate anything else between ETR and ITR, or just I'm multiplexing, that's it?
Well, for example, I don't know, but for example, with the delay, or for example, you can say, okay, I want to multiplex these flows, and I want to use, let's assume, for example, I have a lot of machine-to-machine services or packets, and I want to add a queue because I have a lot of throughput at that moment, a lot of traffic. So I say, okay, I am going to send all the machine-to-machine traffic together, adding using a period. So can I use 100 milliseconds of period? And the other say, no, please, just 5 milliseconds. I don't know. This is the kind of negotiation we could think about.
Okay, thank you.
Sorry.
Xiaohu from Huawei. I have a question on the use case.
Mm-hmm.
You list two use cases. One is VoIP, another is IoT, right?
Mm-hmm.
Okay, for VoIP, if you want to carry multiple small packets within a Lisp packet, have you considered the side effect on the latency and the latency variance?
Yes, well, we have studied a lot of things about the latency. We have papers about that. The idea is that you don't multiplex packets of the same user. If you have, for example, think about 2 central offices of the same company. It's possible that you have 10 simultaneous voice over IP calls between them. So you can take 1 packet from each conversation and put them in the same packet. So you are not adding a delay to each, you are not taking 3 packets of the same conversation, because that would be stupid. That would be like putting more samples in the same packet, in fact. But if you take 1 packet of each conversation, or if from a number of conversation, for example, one use case we have been talking about with some people is communication between 2 asterisk voice over IP PBX, because some people do things with that, and there is a protocol to exchange traffic between asterisk PBX, and there is trunking there. So we could use this like trunking, like voice over IP trunking, but you are not adding more delay to a single conversation, but only when you have a number of them.
Okay. Is there any possibility that a small packet of a given VoIP session be encapsulated on different Lisp packets, though Lisp packets are transported over different passes? In that case, reordering will happen.
Yes, it can happen, reordering.
Okay, okay.
Well,
the locator selection is based on a 5 tuple.
At the mic delay.
Yeah,
5 tuple. But there are multiple flows.
Yeah.
How you determine?
Yeah, for example, if you do 2 queues, one for small packets and other for big packets, I don't know, I am just guessing. Yes, you can have reordering, obviously.
Okay.
But the packet size doesn't determine the locator selection. That's the only point that I was trying to make.
Okay. Another question is for the IoT use case. If I understand the use case correctly, the traffic rate in IoT scenario is very low, right?
Mm-hmm.
If you want to collect multiple small packets and then contain them within a Lisp packet, you may need to wait.
Yes, I am thinking about there is always a compromise between delay and bandwidth saving, but I am also thinking about critical moments. You don't need to add delay.
Delay is not a concern in the IoT, right?
Yes. For example,
yeah, if it's not concern, why not allow IoT device itself to set large packet rather than small packet?
Well, an IoT device can wait till it has 10 samples and then send them together. You mean that? Instead of sending 1 packet every whatever seconds, you can send them together. Yes, it can also be a possibility.
Okay, okay.
Okay, thanks.
The real problem is not the delay, it's variable jitter for real-time services. You need some control plane below, it's like RTCP, if you remember, a long time ago, to do so properly time division multiplexation. Otherwise, you'll introduce variable delay for real-time and it will completely makes unusable.
Well, we have also studied the kind of jitter you would add to this, and yes, you can keep it into certain limits if you want. I mean, we have some studies about the delay and the jitter.
So side comment and study, one thing to do it for 2 megabit line in Intel, another one to do it at 10 gig fast path processor. It's very different scenario.
Okay.
Okay, thanks.
In the past year, we from University Tübingen wrote a new Lisp implementation. Okay, we wrote a new Lisp implementation and are still continuing to write. And I will explain to you first why the hell we did it, then what we did, and how you may use it. So the obvious question is, do we really need another Lisp implementation? And our answer, after a bit of research, was yes. Last year, we wanted to implement our own draft, and then we took a close look at all existing Lisp implementations.
Well, I will say you don't even need to justify it. From the IETF point of view, more independent implementations from the specification is a good thing, not a bad thing. So thank you.
Okay, then maybe for just a short one, Open Lisp, last update 2011, OOR, really hard to read if you don't have much time, and Lispers is not open source. So we want to make it a bit better just for research. We want something for rapid prototyping, so no need to read the code. We want it to be open source, we're not selfish, and we want it to be portable, because if we want to test something, it has to run on different devices. Up to now, we implemented the main components, an XTR. Of course, you can use ETR and ITR as separate components, but to make it easier, I will treat them as one big component for this presentation. From that, you can easily get a mobile node and an RTR using the explicit locator path type. And of course, we also provide a simple mapping system with hash-based entries. This can be, if you really want to use it for a productive environment, exchanged, because it only works with a simple API. So if you want your own storage solution instead of a hash table, you only have to implement save entry and get entry. As I said, we want it for rapid prototyping. So the software has to do as much as possible for you. We wanted it to be object-oriented, so we need a class for every packet, which can also parse itself. So you can make a packet either by entering all its values or by just passing it a byte stream you get from an interface. Then the second goal was the platform independence. Of course, if you think of platform independence, Java normally is the obvious choice. And we combine it with a TAN interface because the TAN tab driver also is available for most systems. If you want to use it on Android without root permissions, you can still use the VPN API. We made 3 modules. First of all, a general networking module for IPv4, IPv6, and UDP packets. So for example, if you want to make a map request, you get the raw IPv4 packet from your TAN device, you just pass the byte stream to the constructor, and then you can get the destination IP address and make your map request. For that, you need the control plane. We implemented all types from RFC 6830 and all LCAF types. From that, at the moment, we only use 2 in our components. Of course, the ELP for the RTR and the NAT type for an NTR we will present in another presentation. Last but not least, we also have data plane to encapsulate and send packets. But if you're still too lazy to read that code and just want to start, we also implemented a plugin system. With that, you don't have to read a single line of code, only the interface shown here, and you can start registering your plugins directly. Easiest ways to do this with an example. So let's assume EID1 wants to send to EID2. So the packet is sent to the XTR, first hook for us. Here the send raw data, you get the byte stream, you can modify it and pass it back to the application. The XTR now wants to get the destination XTR, so it has to send a map request. So you get the second hook, the second from below. You can modify that before it's sent. The mapping system returns the map reply and another chance to modify it. Then the packet is encapsulated, and again you can interfere. It's sent to the other XTR. Again, another option to modify it. And then after it's decapsulated, short before sending to EID2, the last chance to modify that packet. I guess with that system, it's possible to make nearly all small changes without even having to look at the code itself. Of course. I'm at the end of the slides, and I hope for many questions.
Oh, okay. So can I use this API in JavaScript? So if from a browser I wanted to do a lookup in the mapping system like LIG, but have a different interface, do you think it could work with this interface?
I guess JavaScript, we already wrote a LIG, but not with JavaScript, with normal Java. And of course, then you could also use it in a Java, in Beans or something like that. For JavaScript, of course, you need to write an interface for JavaScript to the Java application.
Yeah, I have two questions. So you mentioned open source. In which license?
It's open source, GPL free. There you get a link to the source code.
Okay, and are you thinking about in trying some interoperability tests with other implementations?
Sorry?
Interoperability tests with other implementations.
While we wrote it, we tested it with the OOR, XDR, and the Open Lisp mapping system.
Okay, great.
So quick answer to Dino's, there is the Open Daylight mapping service that exposes REST API. So if you're looking for a RESTful, that would be a solution. And we're definitely interested in interoperability with that as well. So one option. We can talk after.
We could talk about it. Other questions, comments, bashing?
Are you planning to show us a demo sometime?
We could show a demo, yes. Not right now.
Not today. But
Yes.
I mean, it would be interesting to have a look at
No
your
problem.
implementation.
Of course.
Can you run this on iOS or you still need to on an Apple phone?
I'm not sure about Apple phone. For Android, you can use it either on a rooted device with the normal turn-tab driver, or Android offers offers a VPN API. I'm not sure about iOS.
Yeah, I was about to say the same. You need a similar API as VPN API, but for iOS, which exists, and you need to.
It would be interesting because we have been adding implementation on Android, but on iOS.
The point is, with this implementation, you don't need root rights on Android, so you can do it on a non-rooted device.
No more questions? Okay, thank you very much. Next one is John. Yeah. You sent me the slide?
Yes.
As expected. Sorry about that. No problem. Here we go.
Thank you. Good afternoon, folks. John Brzezowski from Comcast. I saw Luigi earlier this year, and he asked me to come here to give you a bit of an update on some stuff that we're doing with V6 segment routing. One of the things about this particular presentation is we're thinking about doing a deeper dive internet draft that kind of goes further than the existing use cases draft in the Spring Working Group. Undetermined when that'll kind of get out, but I'll keep Luigi in the loop, and if you guys want me to return to provide more information, we'll be happy to do that. The use case for us essentially is we have a fairly large network. We have a very large deployment of V4 multicast today, and we're not entirely. And we think at this stage of the game, it's overkill and unnecessary for us to kind of replicate that for V6. So when we first started to do this work with in Spring for V6SR, these are the motivating factors, right? So from our national data centers all the way to our access networks where we where we touch our customers with multicast. Today we have V4 multicast all the way through end to end. And the idea here is that we inevitably need to make V6 multicast available on the DOCSIS facing aspect of the network, facing the customers and their premises. Lots of things in here that I'm sure many of you are familiar with, everything from testing, interoperability, silicon capabilities, et cetera, et cetera. Long list of reasons why we really want to go through that exercise. For about 10 years now, for as long as I've been at Comcast, we've kind of revisited the topic of multicast every year, and up until recently, we really didn't have any kind of pressing need for the same. And then when the need finally arose, it was really only in one very specific aspect of the network. So for us, the intention here is not to sprinkle V6 SR capabilities throughout the entire network. It's going to be targeted for very specific nodes in our network. In this case, it would be the origin application in this case for us, and our access elements, right? So in cable network, the CMTS, cable modem termination system, is what all of our broadband customers effectively connect to. This is really kind of the primary device that we have in bulk at the perimeter facing our customers that would have to support SR, and that work is currently in play right now. In our network, in this initial deployment, there's essentially a very small number of SIDs. The origin, which will be a multicast server of ours, would essentially insert these, unicast them to the CMTS, and the destination address will be the multicast group that is being sent to. We would have a telemetry backend that we would use to kind of decide, which multicast data payload would go to which CMTS and which group. And as far as this is concerned, we have a prototype that's working. We can show bits and pieces of it in bits and bytes today. We're hoping that come first IETF next year in Chicago, that we will bring kind of a real access network components that will show this functionality, including the origin server. This is a picture, and what you'll see here is this will be our origin server, where the part that's missing here is kind of up top. We'd have a telemetry database that we would, or source of telemetry that we would use to query, make some decisions around where the packet was going, and then in our case, this is kind of the portion of the network. Obviously, the cloud picture over kind of under represents kind of the complexity in here. There will be many routers, links, and hops that happen within here, which will basically be links and hops that we don't have to implement, PIM or WAN multicast support for. CMTS is here, and then of course we have the destinations, and then down below here is where the households and the customer premises would be. A more advanced use case would be, actually this is a kind of a extension of the first one. This would be basically in a case where we have to send these packets to multiple CMTSs. Our expectation at some point would be that we will have to leverage this approach to send to every CMTS in our network, and there are thousands of them. So they'd be unicast packets to those CMTSs. One of the things that we could also do here, and I think, nope, I didn't put it in. One of the things that we could do here is if all these CMTSs are, say, in San Jose, and Robert and Dino happen to be, grouped in an area where I know that, there's going to be other people like them where there are a high density of people, what we could do is we could put another one of these origin servers, because it's effectively like a CDN node, right? And we could drop one in here, and then it becomes yet another SID in the SRH that we could use as a destination, and then it in turn would then kind of replicate down to the CMTSs.
Yeah, about traffic. So this is super interesting, and we have to talk offline. Sure. For my own use case. But where is Lisp here?
Today there's not.
I can explain. As John started, we met in Paris. I found the use case interesting for Lisp, and he clearly stated, "I'm not using Lisp," but I said, "Yeah, come, just describe the."
I think I'm about to learn.
Interesting stuff. Who computes the full stack?
Say again?
Who computes the full stack?
The origin. So we have an origin system and telemetry database that goes with it. So we could basically determine which parts of the network we need to send these packets to, but the composition of the SRH effectively is embedded within our origin application.
So you don't use your link state use database to build the full stack? That's correct?
That would factor into those decisions, right? It would, but in a very simple model, if this link is down, I have bigger problems.
Yeah. So there's no dynamic recovery.
It would be dynamic, but like I said, it will be dynamic in the sense that I don't. In this case, it's like on or off, right? If I cannot get to this link, the loop back on this particular device, I've got other problems, right?
Have you considered some invent NM, so path protection in a way till the replication point?
I don't. What do you mean?
I mean, if your path to the replication point goes down, you could use another MDT.
Yeah, I don't see why we couldn't do that. Yeah.
It's really cool stuff.
Thanks, Professor.
Don't give me so much credit. Can you go to the replication side, the head end? So I was going to ask you, how do you avoid head end replication? You answered the question. Did you, by putting another content server somewhere closer to the common receivers, but did you consider putting a router type device in the middle so the top x86 would just send one in and then you would replicate closer there?
Yeah, that's a very interesting conversation. So I had a conversation with ICE about regarding beer. I think that's kind of thing. And what we said, so this is a learning process for us, Dino, right? So what we're, and what happens inevitably is contrary to what people may perceive, we're not going to push those lower level caches down from day one. How we're really going to do this, because I've been doing this for a long time, we're going to say, hey, you know what? We're going to go to San Jose. Let's try it out. Let's serve Dino and Robert and everybody else from Denver. See how it goes. Oh wow, look, this is working great. Look at all this unicast traffic. So then we're going to say, let's break out the checkbook. Let's put one of those nodes down here, okay? But maybe Seattle is still low volume, so we'll still feed it out of Denver, right? Mm-hmm. So inevitably, when those events happen, whether it's a remote cache node or like a router, mm-hmm. And I have to admit, I am fascinated by kind of the opportunity that beer represents. Mm-hmm. So I view it as an optimization, right? So as we learn about what happens here, and this is exactly what I said to ICE, mm-hmm. I said, you know what, let's keep talking about that and kind of vetting that out, because I think the replication component is interesting. The one thing that we need to kind of still think about is, we're trying to kind of take the complexity out of the underlay, right? And that's kind of putting some of it back in. Right. But you know what? I mean, if it just works, then maybe it's okay.
You'll add a new data plane machinery, but you won't add any control planes. So it's hopefully a small addition versus what it could be otherwise.
I think it's very interesting the work that's happening in beer.
Okay, and is there any cost to doing segment routing to the underlay, the middle of the network?
No
I mean, products just switch IPv6 with option headers with no problem.
Thus far, and at this stage of the game, we'll make sure as we kind of dip our toe in this water. And I think the worry here is like, is there like merchant silicon type products that might throw up all over some packets that have like larger headers. Thus far, no. And what we're doing right now is we're funding some research with some folks who do measurements to really kind of make sure that because that would be pretty uncomfortable, right? You start sending packets with SRH and you start blowing routers up. That would suck.
And do you have any traffic engineering requirements? Because Lisp could solve that for you.
I'm overdue to have a long sit down with you about Lisp. So we should do that. Traffic engineering in this case in particular, I don't think so. I think this one's pretty simple, but I think as if Luigi wants me to come back, we can start to elaborate on some other more advanced use cases, because there's another one that's coming up. Also, there's actually two where I do think I know that would be a factor.
Robert again. So yes, I was talking to Stefano about this particular solution, which you and John were talking to him about, mm-hmm. and actually I see some perhaps opportunity to merge Lisp knowledge with the segment routing, because you can actually apply this replication in Denver to me and Dino in San Jose using just static configuration or YARN configuration to the node in Denver for segment routing itself. So he can replicate packets based on the incoming segment IDE, right? So that's actually something which perhaps there is opportunity to bring together and use efficiently.
You're refreshing my memory. Few months ago, when we were still kind of like really kind of exploring the bookends we were trying to do, I was talking to Brian Field about this, and we were actually talking about using Lisp. There was some conversation around Lisp as a control plane as you're describing, and at the time we just we didn't think it was a mandatory element for us to kind of move the kind of solution forward. But like I said,
there is some.
I'm long overdue to spend some time with Dino. So
it's some overlap between RTR functionality and SR node functionality, and those are kind of competing each other. So.
So back to your comment about merchant silicon. So I've published a few drafts how to signal label depth supported by a device. I was targeting in PLS mostly, but if you're interested to signal same capabilities for V6, I would more than happy to extend it.
Yeah, if you wouldn't mind sending me kind of a pointer, so
Yeah, I will do
can
so.
avoid, internet drafts, blindness, that'd be great.
I'll do so.
Yeah, that'd be great. I think that's everything I had. Thank you very much for the time, and Luigi.
Thank you, John.
Thank you.
You're welcome to come back with more use cases. Dino, you will use your own device as usual.
Do you care which order I present it? Can I do the easy one first?
As you like.
Okay.
It's not a big deal. I mean,
Yeah, just, I'll tell the people on the Meet Echo that you'll be using.
It's not enough for me.
but you stay in the pink square, huh?
How much time do I have?
Uh, Less than an hour. You have 40 minutes, actually.
I think we'll do opposite.
So make sure you tell people which piece you're doing at each point.
Yeah.
Okay.
Be clear on.
Okay. So I'm going to first talk about the 3 internet drafts, which are some basic Lisp features that are in 3 separate internet drafts. So it's the presentation, some new basic Lisp features. And those are the 3 drafts. A really simple draft that says, how do you encode names as EIDs and register them to the mapping database? Finally, being able to define the use case for geocoordinates and geoprefixes in the geo draft. So geocoordinates or geoprefixes can be used as both EIDs or RLOCs. I'll talk about that. And a really simple idea with EID anonymity. A host could talk to a server and keep changing its IPv6 address, and it could be anonymous on who it is. Okay, so, technology's failing. Okay, so we can encode in a distinguished name in the AFI list. Aha, it's delayed. Okay. Come back. Yeah, my watch is late earlier. Yeah. My watch earlier said I needed to stand up while I was doing the presentation. So we can encode distinguished names as an EID record or an RLOC record with just standard AFI encoding, not an LCAF. The AFI list has a value 17 that's called distinguished name. So this is actually very useful. In my experience, it's very self-documenting. It's kind of a free-form encoding if you want to use it, but it's pretty self-documenting in mapping database, and I could show you some examples of that. You could also provide multi-stage lookups for additional level of scalability in the mobility case, which I'll show you as well in an example. And it is actually supported with Lisp DDT kind of by accident, but with no changes. And for an example, if I wanted to look up the EID/root/Dino/slides/Berlin, maybe the DDT roots children is delegating /root Dino to 2 map servers that actually have root Dino slides Berlin registered. So you could actually do long and partial matches this way. So let me show you how this can work. So this is an entry in the map server in the Lisp mapping database system. And up there on the top where you see the blue circle, it says an instance ID 1. So this G-XTR1 is an XTR in a VPN described by instance ID 1 that you can actually have a bunch of RLOCs, which are the list of RLOCs down on the bottom. And then the RLOC name shows you how the distinguished name could be part of the RLOC record as well. So that's distinguished names. Geo. So we already have a way to encode geocoordinates as RLOC records, and the general encoding was defined in the LCAF document. I wanted to experiment a little bit with geofencing, and if you add a radius value to that geocoordinate encoding, you could now build or draw a geographical sphere on a map. So you could actually make it 2-dimensional by defining a point and a radius in kilometers and build a 2-dimensional. Or if you also include altitude in the geocoordinates, now you can build a sphere. And so you can do some interesting things. You know, for instance, this sphere could be, or let's say it's a 2-dimensional circle, can be the San Francisco Bay Area. And then I can ask a question to the mapping database. Say Joel is registered a mapping system with his geocoordinates. I could ask the question to the mapping database, is Joel in the San Francisco Bay Area? If so, warn him there's an earthquake happening. or something like that, or he may know himself. So these geo coordinates can actually, so the geo coordinate, I'm redefining it in this document as a geo point. A geo point is a single point. That was Joel. A geo fence or a geo prefix is actually something that is a geo type geo fence. So let me show you how it can work. So here's an instance ID of 1000 up there. This is a Lisp site command in the map server. And then I have a bunch of distinguished names that are being advertised: San Jose, New York, Paris, London, Tokyo, SJC, which is the airport code for San Jose, and CDG, which is the airport code for Paris. On the left-hand side, on the bottom, you see the actual entry. And what it's showing here is Paris, and this is the geo prefix. Why is it a geo prefix? Because it shows you the point and 100 kilometers.
You have a pointer here.
Oh, there's a pointer. Where? There? So the wrong people were delayed. This one right here, the right thing?
Yeah.
Okay. Yeah. So this is the ID Paris. That's the geo prefix because the /100 says that that's the point and it's 100 kilometers. So it's building an area on the map. CDG is the airport and it's being registered with a geo point. So what I could do now is I can say, is CDG inside of Paris, right? So what happens is we actually look in the mapping database and look up CDG. We get, from the mapping database, we get the geo point. We convert it to the decimal version of it. And then we also look up the geo prefix Paris, and we get the geo prefix. So it's centered at that point with 100 kilometers. So by doing a compare, you can say, yes, CDG is inside this circle, and it's 23 kilometers away from the center of Paris, or wherever I obtained that geo coordinate. So this is kind of interesting because now when you can do RLOC selection and decide to encapsulate packets to an ETR that may be close to an EID, because now you have physical location. Physical location may determine signal quality. Not always, but there's a better chance than something that's farther away. Okay, next spec. Fibonacci Lisp EID anonymity. This is a client that can allocate ephemeral EIDs to itself. And this can be strictly done on a particular host. So let's say, and what I propose in the spec is to use the 2001:5 IPv6 prefix that was allocated for Lisp to do experimental EID allocation. So I said, well, let's use 2001:5:FFF, and let's register ephemeral IDs with a current RLOC set. So basically, I come up, I just pick this arbitrary IPv6 address, I start sending packets. The ITR that's close to me has his RLOC, he registers it, okay? So you source the packets from the ephemeral ID, and then any return packets that come back from the server just looks up that ephemeral EID, finds the RLOCs, and starts encapsulating packets. This is simply a mobility problem, right? Because I can have a fixed or global address and move around where XTRs dynamically determine that something has popped up. If I stay still and keep changing my address, it still looks like a mobility problem because there's just either a new system or the same system with a different address is coming up. So there was 0 changes to the Lisp protocol. Okay, let me show you a demo of that. So there's a client side on the left-hand side. It's sitting behind an XTR. Its RLOC is 3. And the RLOC on the other side where the server is 4. This is an address that's fixed because the server is bolted in a rack and not moving around. The client will use a random number generator to generate a value for the low order 64 bits. And then what will happen is so what I did is on the client side, I wrote a script that keeps changing the IP address and sending pings to the server. So you can see that, but I can't see. You can allocate, I'm allocating this address, IPv6 address, and I'm sending it to 4:4, which is a static guy, and he sends the packet. Now, as he sends the packet, the XTRs are registering them to the mapping database. So these are previous EIDs that I sent to, and these are the current ones. That shows you 3 different ephemeral IDs. So it's kind of interesting because now I can come up, go to Google, and then shut down, and then there's no trace of me ever again. They don't know who did that request. So if you want anonymity in the EID and a little bit of clear text confidentiality, you could do it with this. It costs nothing extra from Lisp or protocol changes. It just does, if you do the EID mobility spec, you get this for free. So just an FYI. Questions, comments?
I have a question on this last one. How you do duplicate address detection? I mean, it is a huge space, but still you can have, by any chance, a clash.
Yeah, haven't figured that out yet. Good point. 64-bit, random number 64 bits is pretty random.
Yeah, it's huge. But
And
yeah,
actually, we have more high order bits, so we can even use more. But yes, this could be a problem.
and
And well, I'm hoping that these ephemeral addresses, that these EIDs will only be used for a very short period of time, and that will help. Because as soon as you start sending and you make a TCP connection, you shut it down, then the host will actually, we have to figure out a way to quickly deregister address. So if somebody does come in later with the same address from another location, that happens.
but in IPv6, you already can generate pseudo-random temporary addresses. Yeah, there is an RFC.
Okay.
So
Okay, so we don't have to do anything.
yeah.
Okay.
So look at that one, because in that one they discuss already
So
these issues.
So Luigi,
I mean,
this is kind of a best user practice. There's nothing, it's just documenting what could be done. And by having a little level of indirection, these ephemeral EIDs can actually be mobile. So maybe that's what this idea brings to the table versus just being random or whatever.
yeah.
Yeah, okay.
Look at that.
Got it. Any other questions?
On any of the presentations so far, right? If you, any question? Nope. Go on.
Okay, so this is not any new technology. This is just documenting stuff that's been working for a long time in two of the drafts. I guess the third draft is something new, which is the predictive RLOCs, which will be the presentation after this. The 3 lines there of authors, the first line is Lisp mobile node, the second line is the EID mobility draft, and the third line is the predictive RLOCs. Those are the authors of those respective drafts. Okay, so this presentation was given at 5GAIN IP to show them that Lisp could be considered as a mobility solution for 5G. And predictive RLOCs was presented just now at the ITS, the Intelligent Transportation System BOF, to say how the mobility features of Lisp can be used for moving cars and self-driving autonomous systems sort of stuff. So I'm going to discuss in this presentation why Lisp can solve the mobility problem, and that we have 2 forms of separation, and how handoffs could have near zero packet loss. Okay, and I'm not going to tell you what Lisp is because since you're in this working group, most people know about Lisp, so you don't need the 1-minute overview. So there's really only 3 ways to solve the mobility problem, and if anybody has a solution that thinks it's different, it probably fits in one of these 3 ways: host routes, the notion of a home or home agent, or using locator IP separation. Okay, well, if you want to solve the mobility problem with host routes, it's kind of a non-starter, because if something moves and you inject an underlying routing, you want to move fast and you want to talk to everyone. Getting that route propagated, getting a single route to a single system propagated all over the internet, you can see by now, just by the tone of my voice, it's going to be really hard to scale. You just can't send routes the entire internet fast enough to get good handoffs. And not to mention, there's simply too much state. And there's also policy restrictions where not everybody's going to accept /32 or /128 routes because they're very specific and they don't want to blow up their routing tables. And then with multi-homing, if I have 2 addresses and want to use both of them and I want to move around, do I have to inject more routes into it? So just the fact that every phone is multi-home, now what I just told you is ×2. So the problem just gets worse and worse. Notion of home, where if you use the mobile IP approaches that have a home agent, if you're moving around, there's really no home location. So what's the point on attaching address to some piece of topology that's in the internet that you may not be there ever, or you may be there temporarily? So trying to extend you being on something that's far away, saying that I'm still on the subnet, but I'm really not physically attached to it. Those sort of semantics probably are no longer useful in this mobile world that we're in. So conventional wisdom says that We also have this triangle routing problem where anything that has to come to me has to be tunneled to my home location, right? And then if I'm multi-homed, do I have multiple homes? Do I have multiple addresses? Who do they tunnel to? And if I roam to a high bandwidth area and my home has less bandwidth, why am I going to be subject to that low bandwidth if I'm now in a high speed channel somewhere? So this doesn't really work very well. Everybody wants shortest path, low latency. That's the world we live in. The locator's ID separation really is the only solution where you can keep the moving entities addressed. You could keep it fixed, and that's called an EID. And that has benefits in itself because you don't have to do address maintenance. You can assign the EID once at manufacture time, EID allocation could be done once and you never have to think about it again. It's not even a subscription time thing, it could be coarser. Like you're given a first and last name when you're born. I'm hoping one day we can give you give all your children an IPv6 address when they're born, and we call them EIDs. That's what we want to do. And as the location changes, you want to reattach to the network as an RLOC, right? So your attachment should be independent and should be freely binding. And this is what locator ID separation could do. So the moving entity is always a single address because it's really one thing that's moving. Okay, what's moving in here? There's some chips and electronics in here. Are 17 things moving at one time? Yes, but it doesn't matter because they're encased in one thing. All you care about is this entire gadget here moving once. And an EID can still be multi-home, but since it has a single EID address, it's multi-home because it has multiple attachment points, which means it has multiple RLOCs, right? So you always get the shortest paths because you encapsulate packets to the RLOCs where currently the EID is. So we have two forms of separation. The first form is that the EID and the RLOC set are co-located in the same moving entity, and that's what Lisp Mobile Node documents. 10 years ago when we started Lisp, we said the best place to put Lisp is in the network, right? And we said that and we were adamant about it, and this draft says, well, maybe you might want to put it in the host, in a mobile phone or something like that. So this is kind of the one exception, but something to be maybe considered. But then we could also have it separated. The EID could be the moving entity and the RLOC can be a stationary network node that supports it, like an eNode B or an S gateway or an access point or a CPE router or a top-of-rack switch, all those sorts of things. This is the example where they're co-located, where the EID is the address of the mobile phone. Maybe it's configured on the loopback interface. And then you get DHCP leases on each of your radios, and those are the RLOCs. So when these DHCP leases are sent to this phone and this phone is running Lisp, it registers that mapping. This is the case where it's the EID mobility draft where the EID is the moving object, but it does not run Lisp. This phone here can also be a VM that's running in a data center. It's assigned an EID, but it doesn't run Lisp. There's something close to it that runs Lisp, a vSwitch, a top-of-rack switch. In this case, it's an access point to a Wi-Fi provider or a carrier-based node somewhere in a 5G or 4G environment. So this is when they're separated. So let's talk about the EID mobility. In EID mobility, the EID is assigned to a mobile device, a roaming service or an application, a VM or container. This is stuff that is an application with a protocol stack that doesn't have to change because it's using Lisp. Lisp is not running in this IP addressed entity. It's running somewhere else. And we've been able to prove this. There's shipping product that does VM mobility, and there's there's shipping product that moves things around in the campus as well. And the Lisp boxes are actually the access nodes and not the moving things themselves. And now the RLOCs, as I said before, can be a base station connecting wireless sort of things like an eNode B or a Wi-Fi AP, or it could be a roadside unit connecting a car in the ITS case. Top-of-rack switch, edge router, all the things I already mentioned could be Lisp boxes that, so if you're a Lisp box, you own an RLOC, people will encapsulate to you. So by definition, if you're a Lisp XDR, one of your addresses, you're going to register with something. It's a configured distinguished name, or somebody, an EID that you learn dynamically, or it's configured statically. You are the RLOC. You're offering that data plane service. And so what the Lisp EID mobility spec actually introduces is discovering EIDs dynamically, Because in the past, what we did is you have two CPE routers. They're connected to a site. The site has been assigned 10/8, so they're both configured with 10/8, and each of their IP addresses are registered to the mapping system, so you can do multi-homing. That was the static database mapping thing. All we did with EID, with the Lisp mobility, is saying, well, EIDs can be learned. If you hear packets from somebody on an interface, you can do mission control locally there and decide if you want to learn it. You learn it, you remember it's back on this interface. Now you register myself with that EID, and then people can encapsulate packets to me, and I know where to forward it. And this is working. So this single solution, this EID mobility solution, is working for all these use cases. So the final, and so then my next presentation is actually going to talk about predictive RLOOKs, and that's the new draft. And this is an example where when you discover, what I was presenting before is when you discover an EID, you're doing control plane signaling at the time the move happens. So Joel roams onto me, I'm an XTR, I just discovered him. He wants packets from people, right, from places. So I register so they can start encapsulating. Well, Joe's gonna be waiting around for a little bit, because until he sends a packet and until I register it, until the caches are updated, he's still waiting for data, and he might want data really quickly, right? So what we want to do with predictive RLOOKs is we don't want to do any signaling. We want zero packet loss, okay? And you know, rather than talking about this, I'll just go straight to the next presentation, unless anybody has any comments on the other stuff.
Can you turn slide back? No, EID mobility. Yes. If I remember correctly, you have said you recommended to use network-based Lisp for mobility, even for the internet scale mobility, right?
Yes.
Okay. The DDoS attack on the ITR cache is still an open issue or have been closed?
I'll let the researchers answer that question.
What?
I'll let the researchers, somebody behind you shaking their head.
Okay,
no.
okay.
So
okay,
I'm
okay.
sure Luigi,
Okay.
I don't know if you were shaking your head.
The third item, who informs encapsulators to get new mappings? ETR?
Yeah, ETR.
If ETR, ITR are located on different networks which are operated by different operators,
it still works.
What's the trust relationship between them? How can ITR trust the ETR?
Okay, great question. So an ITR, when you want to talk to Joel and I'm the ETR for him, your ITR is going to send a map request. It's going to come over the mapping system, and I'm going to get the map request and send the map reply. In a secure system, I use LispSec, and I sign that map reply so you know it's coming from me, okay? And the reason that it's secure is because I'm also registering Joel in the mapping system, and the mapping service is also verifying that Dino's allowed to be the XTR for Joel, okay? Now, if Joel moves to somebody else, okay, and that new guy wants to register himself as the RLOOK, he will send you an SMR, a solicit map request. That just simply tells you to solicit a map request, send a map request to the mapping system. The mapping system now will deliver the map request to the new guy. He will then send a map reply back also with assigned value, okay? And you will know it's from somebody new. Now, the big question is, should I trust this new guy or not?
Yeah.
Well, that guy is also validated by the mapping system to accept Joel as an EID as well. So if the mapping system is in partnership with all the XTRs to fool you, then the system will fail. But that's a lot of security that I just described built in that is, I think, relatively secure. I mean, other people may have opinions, but.
Does it mean it's not possible for the ETR to directly inform the ITR of that mapping? You need assistance from the mapping system.
And you do get it, because the map request travels through the mapping system. When that ETR sent an SMR, he sent it directly to you. You as a conformant operating in secure validated application will send a map request to your map resolver. That will find itself to that map server that's been validated. and then forward it to the ETR. So that's the third party where you're trusting. And you're actually not trusting the entire mapping system. You're trusting the map server.
Okay,
right?
you mean the ETR is just responsible to notify the ITR there a new mapping. Then the ITR need to request the mapping server to get real.
You got it.
mapping.
Exactly.
Will this make the handover latency
We call it 3
larger?
halves RTT because of that messaging. That's why we're going to do predictive RLOGs because it's faster. So I said in the ITS BOF, and I got my hand slapped, but I'll repeat again, and then Joel will slap my hand, is that if anybody tells you in any kind of mobility scenario that they will never drop back packets, they're really lying to you. Because in mobility, it's a very hard problem because packets are already in the network going to the old location. And if the EID is moved from that old location, the packets are going to be dropped on the floor. And when the EID goes to the new location, it's waiting there, like I showed you with the Joel example, it's waiting there for packets, but the signaling has to happen, right?
Yeah.
So the thing is there's latency in startup and you're dropping packets in the network. And then a lot of people say, well, have that guy, where the packet's going, have that guy queue it and send it that way. Well, now that you have triangle routing, just like mobile IP, you increase the opportunity of packet loss because you're going through more hops of the network. Obviously, if you go through the shortest path network, you may have less opportunity. Not always guaranteed, but less opportunity of packet loss because the packet has to travel through less hops and through less links and everything.
Well,
It's
Dino,
all subjective.
let's be clear. There's network traffic loss, and none of us can prevent that. But putting aside network packet loss, there are complicated, and I grant you, they're very complicated mechanisms to do all the rest of the thing to make sure there's no other source of packet loss when people move. And I don't think we want to get into an argument with 3GPP about whether these are good, bad, or indifferent things to do. So yeah, there's trade-offs. I happen to like the ones in the Lisp mobile EID, but let's not claim that there's serious problems with other people's work, please.
So predictive RLOGs is going to come up next, and hopefully we've solved this problem in a much non-complicated manner. But you guys can judge.
Sorry, I just
We do need
inserted
to move
here.
along, so the micro folks lined up can talk. Please do ask your questions, but then nobody else should come up until after Dino has
Yes,
gone
Wolfgang.
on.
Just more coming back to a more simple question. And this comes back to your iPhone picture being dual homed. I think we all know the pain. Typically, if you roam to Starbucks or to some shopping malls, whatever, you always get blackholed because this is the higher bandwidth interface, but you don't get any connectivity until you say, yes, I agree on the next side. So if you're talking about predictable airlocks, can we have a solution in this content to not route packets or black hole packets over my Wi-Fi interface until I really get connectivity out of this interface to the internet?
Let me present predictive RLOGs and tell me if you think that's what you want.
Okay. Exactly.
Thanks. Okay, so as for the DOS attacks to the map cache, right? So this has been extensively studied by experimentation, mathematical modeling, and of course there is a trade-off between the size of your cache and how many traffic do you actually need to provide an effective attack. Okay, I can forward you the paper if you want. All the details are there. Yeah?
My concern is that in the original Lisp specification, the mapping is prefix-based granularity. But when you want to support mobility, it's host route-based granularity.
A /128 IPv6 and a /32 IPv4 address is a prefix.
Yeah, it's prefix, but the volume, the mapping table become very, very large.
The volume is however many entities you have. The length of the thing is almost irrelevant. The volume is how many entities are you choosing to track individually. It doesn't matter whether it's V4 or V6. If you're tracking 1 million guys, you got 1 million entries. If you're tracking 100 million guys, you got 100 million entries.
They're not all in one
V4
place.
versus V6 doesn't change it.
They're not all in one
It
place.
is
That's
not
what's
list
important
related.
too.
If you want to track 1 million guys, you need 1 million entries, no matter in which working group you are.
I mean, in the DDoS attack scenario.
So
Let's not get into,
Given
let's
host-
not get into security threats here now. We don't
anybody-
have time to do it.
Anybody else?
It's not that that's not a reasonable question. We don't have time to do the analysis and discussion
Can I
of
give a short
DDoS.
answer? There's
Very
no
short.
There's no short answer. So the short answer is people won't let anybody just be automatically EID discovered. The way that they're going to deployment is they're going to do admission control on the ETRs to say these are the only things that are going to be allowed to be roamable. I believe that IPv6 EID prefixes will be assigned as a mobility prefix, and only certain guys will be able to roam. Like maybe if I have a US prefix, I won't be allowed to roam to Berlin, right? Because it's how do you roam fast to Berlin? I have to get on a plane and go 10 hours, right? You know. So I think there's going to be, and I'm getting wrong.
You are venturing.
That's a complicated problem. Let's
Ask this.
It's invalid, but we need to. That's for a list discussion.
Yeah. Put it on the mailing list so that you can have also pointers on what. Sorry.
So I have a question on the EID mobility. So you discover a new EID, and then where do you map register it?
You map register to the map servers you have configured.
Which are pre-configured.
Yes.
And how a map request towards that EID will reach that map server?
The same way it does normally, because it's registered, it's part of the DDT hierarchy. And so you have to make sure that the EIDs that are being registered are part of the delegation for those map servers.
Lisp mapping is a static or quasi-static allocation-based system, so it isn't affected by your mobility during your operation. That's just the nature of Lisp. It's why it works for separating EIDs from locations in the first place.
The reason mobility works is because everything is moving around, but the mapping system is completely static and still.
But then you discover a new EID. So you know in which map server you need to register that, because it's the map server which is responsible for that prefix, right?
Yeah. Yep.
And which password do you use?
The password that you have configured with the map server. It's not always,
But
it doesn't.
then you need access to all the map servers. You need
No, not true. So okay, this is how it can be deployed. What you say is there's a mobility prefix, and maybe all the XTRs that are in Germany will allow the
8 minutes.
Can we take it offline? Yeah.
Thank you. Still have time for me?
We always have time.
Okay, yeah.
On the list as
Speaking
well.
about the packet loss in the mobility case, right? So I can see that the packet could be lost. So the communicating nodes send you somewhere, but actually you already moved away. So, but applying the predictive RLOCs together, and also suppose at some node you don't know actually your next stop or your next RLOC yes.
Sure.
So could that applying like a multicast here, just
Oh,
send it to all the places?
I'm going to present that now.
Oh, okay.
Yeah, yeah.
Okay, thank you.
That's the predictive RLOC solution, actually. Should I go? Okay. So the mobility problem is simple. When EID moves, you send packets to a new location, right? We just had huge discussion where that's not true. Now, the problem is because the packets are going to the old location where the EID is no longer, and then the EID shows up at the new location and it's not receiving packets. This is actually, mobility is a very hard problem, and no one's going to dispute that. Now, this solution, or these solutions where you signal when you see somebody arrive, is not make before break. It's reacting when the situation happens, and that's why you're going to have packet loss. So these are struggling solutions with mobility. Mobile IP, you can't send to the home agent because it doesn't know where the new location is, right? It has the same sort of problems. It has to find out where the new location is. And when you roam to the foreign agent has to signal using either simple or complex mechanisms. We already talked about host routes. And locator ID separation could be a good solution if signaling is fast, right? But you just mentioned how there's a lot of packets going back and forth. How fast can it be when you have to do that kind of signaling, right? So we really don't want to drop any packets. We want handoffs to be instantaneous. Okay. What if we know about all the solutions? The future is clear. You know where the EID is roaming, right? We'll have the source send to all new locations, and we'll search where the EID is roamed to. We're not looking for it. We're sending packets to all the places it will be. We may send it to places where it may not be, But what we're doing here is exercising a bandwidth signaling trade-off, where we're not going to do signaling because we want to reduce packet loss, but we have to send packets where we may be wrong. And this is how it can work. So let's say we register its distinguished name called Main Street, and let's say it has an RLE encoding, A, B, C, D. Let's see these are roadside units along a road, and the EIDs are cars that are traveling along. And let's say both EID A and B are pointed to the same Main Street, which they're sharing the same RLOC list, right? So this is where you can use a level of indirection with distinguished names, right? So let's say a server wants to send packets to this thing that's moving, right? And in the case of EID A, you want to send it to A, B, C, and D because you really don't know where A is, right? There's no signaling, but you know that it's on this road. At some point, you know it's on this road, okay? So what happens is the XTRS over here basically takes a unicast packet, replicates it, and unicasts it to each of the RLOCs in this RLE, this replication list entry. XTRs replicate to all RLOCs. If the packet arrives at an XTR, packet arrives to all XTRs. If the EID is discovered, which is the case for XTRA, the packet is then delivered, right? XTRA does a dynamic EID discovery, and then it goes ahead and forwards it. B, C, and D don't know anything about EID. They haven't discovered it, so they drop the packet on the floor. There's no control plane signaling for STRS to stop sending to A for EID B. So B now has gone down the road. It's wasteful for it to send to A. It's wasteful to send it to C and D, but we don't know how fast it's traveling. We don't know what the overlap of the signaling is. We have to give it to C because even though it's on B right now, it may be past B. But what we want to do is optimize the amount of extra replication. Now, if for some reason B sends a packet back to the STR, which it will for bidirectional communication, XTRS will know that it no longer has to send it to A. So it stops sending it to it. Now, XTRS has a cache that it's forwarding to, and it has A, B, C, D in it. When it decides it wants to stop sending to A, it's a local matter, a local decision that it handles in its cache. It doesn't have to ask anybody else.
Do you know there seems to be an assumption that you know the direction, because if the car is traveling in the other direction, then getting a note from B doesn't mean stop sending to A. It means send to A more urgently, in fact.
Right. This assumes directionality. And this is why we termed it as a train going down the train track. The use case is a train going down a track, a car going in one direction, because what if C is coming in the opposite direction? Then you have to have DCBA. But we can solve this problem as well, okay? What we can do is we can put these XTRs in geofences, and we can decide which direction it's going. You could add, now the thing is you have to have this information ahead of time, but as it's moving, you have to decide when you go get the information from the control plane, can you do it at coarse time frames where you don't have to depend on packet loss? This might help as well. Next example, intersections. So what happens here? Well, we can have something called Main Street, and we can believe that we also have something called Wall Street. In the Wall Street, how am I doing on time, Bad? 3 minutes, okay. 2 minutes, okay, this will be the last slide. So we can be on Wall Street, basically, and we can say that if you look at the RLE, we can assume that the car is going to go to A, B, C, D going straight. But there's a chance it can turn left and go northbound, which you see up here. You see up here with RLOC 1 and 3, or it can go southbound, it can go this way, right? So the question is, at this point in time, what should the XTRs do? Well, let's say it's still going straight, so it does what we said on the last slide. It goes ahead and replicates to A, B, C, and D. Now if the EID moves to B, we don't know if it's going to make a turn. So the red arrows are showing where you should replicate to anticipate where it might be. Okay, so maybe we replicate to B at B, 1, 2, and C. Now geofencing could help us here, especially if they're large ranges, and depending on how fast the EID is moving on the road. That's going to be what the interesting research is going to be, Albert, take note. So we can actually decide if we should go one way versus the other. So, so I think that's about it. That's all I'm going to say. That's it. So what are the protocol changes? Absolutely no protocol changes. Okay. We use the RLE and LCAF And we're just taking unicast map cache entries and replicating. And I actually have a quick demo.
Not now.
No time for a demo.
Do I have time for 2 slides?
Man.
1 slide. That's the EID that's moving. That's the ROE. And a packet's being sent to 222 from 111. And the map cache entry says replicate it to 3 places, and that's what it did. Here, how's that? This is the work that we still have to do.
It's too long. Thank you very much, Dino.
And we are now out of time. Thank you all.
For any question on this last presentation on the mailing list, please. And there has been a lot of good discussion. Continue on the mailing list. See you next time in Seoul. Thank you.
How are you?